Hey, fifth graders, we are here today with Chapter 6, Lesson 4. It's a hands-on, meaning we are going to model the multiplication of decimals. So what are we learning about? We're learning how to model decimal multiplication. Okay? So first, let's figure out how we would draw it. So I have a 100 frame here. It's 10 wide by 10 high. And we are going to model 3/10 times 7/10. So the first thing we'll do is we'll shade 3/10. So I'm going to pick a color here. I'm going to shade 1/10, 2/10, 3/10. And then in the other direction, we'll shade 7/10. I'm going to switch colors here. 1, 2, 3, 4, 5, 6, 7. So the question here is where did our two shadings overlap? So that would be this part right here. I'm going to make the yellow a little darker where it overlapped. Okay, and that is 3 high by 7 wide. Well, let's think about this. There are how many hundreds in the shaded region? That'd be 3 times 7. That'd be 21, right? 7, 14, 21 in the shaded region. So the shaded region represents the area of a rectangle that is 7/10 by 3/10. And so 3/10 times 7/10 is 21 hundredths. Mind you, this is 100 squares, right? 100 in all. How many did we shade? We shaded 21 of the 100 squares, which equals 21 hundredths. So what are we learning from this that we need to remember? When you multiply tenths times tenths, you get hundredths. Hundredths. There we go. So that's a good thing to remember. Anytime you have tenths times tenths, the product is going to be hundredths. So let's think about this here. How are the equations 3 times 7 equals 21 and 3/10 times 7/10 equals 21 hundredths similar? And how are they different? Well, what's similar? They both involve the multiplication fact 3 times 7 equals 21. What's different? Well, 3 times 7 is dealing with whole numbers. And 3/10 times 7/10 is dealing with numbers that are part of a whole. Numbers that are part of a whole. Other than that, they're pretty much the same. How is using a model to multiply 3/10 by 7/10 similar to find the area of a rectangle? Well, what's the formula for the area of a rectangle? It's area equals length times width. And isn't that what we did up here? We did 3 times 7 to find the area of this rectangle right here, okay? So the only difference really is that we're finding the area of part of a whole, okay? So we are doing the same exact thing, finding the area of part of a whole. So let's take a look at 4/10 times 2 and 4/10. And we will model this. First, let's model 4/10 all the way across. Why are there 300s frames this time? Because we have 2 holes and a little bit more, okay? So first the 4/10. 4/10 of each of these 3 holes. So like this, okay? And then, I'm going to color that like that. We'll erase this, change colors. The 2 4/10, let's go the other way. So 2 and, that means 2 wholes. So I'm going to scribble a little bit here. I'm not going to color this perfectly. Okay, so 2 4/10. So I need 4/10 more. 10, 20, 30, 40. Okay, so what now we need to figure out what we colored of this region right here. All of this where the 2 shadings overlap. That's the part that will become the product. All right, so this is 10 across this way and 4 this way. So there's 40 shaded here. That would make this 40. And then this one is 1, 2, 3, 4 by 4. So this one's 16. What does that add up to? 40, 40, and 16. 6, 4, 8, 9, 9600. So let's shade this. This right here will be our combined model. So it's going to be 90, almost the whole thing. Almost the whole, but not quite. Okay, there's 90, and then I need 1, 2, 3, 4, 5, 6. There's 96. A little bit sloppy, but you know. Okay, so what have we got over here? Shade a rectangle that is 4/10 unit wide and 2 4/10 units long. Shade the same amount of squares on a 10 by 10 grid. That's what we did right here. So there are 9600ths in the shaded region. So 4/10 times 2 4/10 is 9600ths. And we can put a 0 here if we want, indicating that there are no whole numbers in our product. Without using models, explain why 2/10 times 3/10 is equal to 600ths. Well, remember before we discovered that when you multiply tenths times tenths, you're going to get hundredths. Okay? So we have 2/10 times 3/10. 2 times 3 is 6, but we wouldn't put the decimal right there because that would make it equal 6/10. Okay? So we need to put a 0 there and make it 600ths because the overlapping area is only going to overlap on 6 squares. Okay? What's another way we could do this? Well, we have 2 decimals to the right, or 2 digits to the right of decimals. So we start over here, 1, 2. So if this had been just 6 like we originally wrote, 1, 2. Here is our decimal placement. We can't have this open space here, so we have a placeholder of 0 for the tenths place. Okay, the table shows some factors and their products. Study the table, write a rule you can use to find the product of 2 decimals, both to the tenths place without using models. So we have 3/10, 7/10, 2100ths, 4/10, 2.4/10, 9600ths, 5/10, 1.1, 5500ths. Okay? So, rule, first step, multiply as if there isn't a decimal. Okay? So here, 5 times 1.1 is 55, and 5 times 11 is also 55, so we can use that rule. So then our second step would be to place the decimal. Go back and see where the decimal, place the decimal. And we do that how? By figuring out how many digits are to the right of a decimal in the factors. All right, let's look at number 5. Without using models, find, that means solve this, 4/10 times 8/10. Explain how you found the product. Could we show our steps and explain as we go? Sure, of course we could. So first, we could do 4 times 8 equals 32. So what are we doing? Multiplying as if there isn't a decimal. Okay? And then we'll place the decimal. 4/10 times 8/10 equals 32 hundredths. How do we know that? We know because there are 2 digits to the right of the decimal. So there should be 2 digits to the right of the decimal in our product as well. Okay? All right, so step 2, place the decimal. All right, that's it. You get to go try these now. It's very important that you work with the model. Eventually, we'll drop it and we'll just do the math, but it's so much easier to remember decimal placement if you've played with the models first. So go ahead and give yourself the time and luxury to color some models. All right, bye guys.